So we'll start with the main rock types and just some of the basic things about them. So sedimentary rocks, these accumulate at the Earth's surface. And the reason that we're going back to this is one of the main goals of structural geology and geologic mapping is to understand the geologic history of an area, and the geologic history is recorded in both the structures and basic information from the rocks themselves. So it's important to kind of understand what the range of different possibilities of that rocks, what the evidence is from rocks in terms of what they've experienced. So sedimentary rocks, there's two main types. There's detrital, and these are sort of bits, or we could call them clasts, pieces of other older rocks, clasts that are transported from an eroded source. So we'll be talking a lot about geologic events. So if you have a detrital sedimentary rock, like a sandstone, right away you've got sort of two events. You have the formation of some older rock, and then the erosion and then deposition of another rock. So actually three events. So the size of the pieces, so this is abbreviation for conglomerate or a breccia, is the coarsest size. Then you have a sandstone, a little bit finer, siltstone, and then a mudstone. So you're going progressively finer and finer grained to the right here, okay? So the difference here between a conglomerate and a breccia is the conglomerate, the large clasts are rounded, and in the breccia they're angular. So you might remember that things that are more rounded have traveled further. But in general here, we have coarse, fine. So this is a spectrum. The other type of sedimentary rock is a chemical sedimentary rock. So these precipitate from Earth's surface from solution. So there's particles that are dissolved in water, and they come out of the solution. So this is limestone, dolostone. So dolostone is like limestone, except it has a little bit of magnesium. Chert, which is silica, and evaporites. So, for example, gypsum is a evaporitic mineral, or salt, table salt. Next, we'll talk about igneous rocks. So we can categorize these different ways. One way is the composition. So if they have a lot of if they have a lot of iron and magnesium, actually, this word mafic actually kind of comes from this magnesium iron the letters made up of those. Let's see, iron magnesium rich. And felsic. So if they're silica rich, we call them felsic. And then they can either crystallize underground, which we call intrusive, deep underground, or they can be erupted at the surface, extrusive. And so the common name for a mafic intrusive rock is gabbro. For a felsic intrusive rock is granite. And then the extrusive equivalents are basalt and rhyolite. And there's a bunch of other names. Rhyolite. There's a bunch of other names, andesites and dacites, but this is the basics. And then we have metamorphic rocks, which are formed from either an igneous or sedimentary, what we call protolith. So the original rock material. So these recrystallized in solid state from a protolith. And there's two general types: contact metamorphism. So in this case, this is heating due to an igneous body. So there's a clear relationship between metamorphism and plutonic heat source. So let's back up just a second. Another word for intrusive here is plutonic. And we also have regional metamorphism. So this is where there's a large scale recrystallization due to burial deep in the crust, greater than 10 kilometers, typically. Okay, so the same the same rock you might pick up could have been metamorphosed by as part of a regional metamorphism or contact metamorphism. Just looking at one rock, you wouldn't know the difference. You got to look at a map. You got to look at the regional relationships to figure that out. In terms of classifying an individual rock, there's basically three ways that's done. So the first is textural. So this really is this has to do with the appearance So, and a lot of that has to do with the grain size. So if we can't see grains, we call it a slate. If we can see a few grains, and it's sort of a shiny, actually, technically, just the presence of a shiny layering, uh, but not seeing grains. We can see a few might be in there, but generally not seeing individual grains as a phyllite. Then when we have coarse grains that are identifiable with a hand lens, call it a schist. And if it gets really hot, we call it a gneiss, which has layers of different compositions. We also have compositional classification of metamorphic rocks. So we have marbles, which come from metamorphosed carbonates, limestones, and dolostones. We have quartzite, which is a metamorphosed sandstone, sedimentary rock, both of these. We have green schist and blue schist, and amphibolite. So these are all three of these are metamorphosed basalt. But depending on the degree of and the conditions of metamorphism, it has different names. And then we have what we call metamorphic facies or grades. So this has to do more with the severity of the temperature and pressure that they've experienced. So these have similar names, same names as some of these things. So they're named after what happens to a metabasalt at different temperatures. So the lowest temperature typically that we notice is blue schist or green schist facies. And these form at 300 to 400 degrees Celsius. If the rocks get to higher temperatures, we call them amphibolite facies rocks, so around 500 degrees. And then if they get really cooked, granulite facies. This would be like 650 to 750 degrees C.